question, which is on okay, which is from magnetic particle. Can you hear me? Yes, you can hear me, right?
Yes, doctor.
Yes.
Okay. Today we are going to solve one question from few questions from magnetic particle. We already studied about magnetic particle, some basics of magnetic particle inspection. Okay, today is we focus on magnetic particle inspection. So let us read the question first before we enter into the answer. So here the question is an iron, 49% iron, as you could see here. An iron nickel alloy has a maximum permeability of 64,000 when a magnetic field of 10 ampere per meter is applied. So please mute your microphone. Please mute your microphone. Yes, permeability is given as 64,000. Magnetic field H is given as 10 amperes per meter. What inductance? Inductance means we have to find B is obtained, and what is needed to obtain this inductance in a 200 turn 300 millimeter long coil. So here, what are the values given in this question is this is actually the permeability is given. We have to find the permeability of the medium. So what I will do, I will cut, and the question has okay. Yes, just a minute, please. Yes. Okay, again I'm going to repeat the question. We have an iron nickel alloy. Maximum, it's a general question from magnetic particle inspection. Here in the question it is given as a permeability. To make it more clear, I will write relative permeability. Okay, now the question is clear. Let me write one by one. It's an alloy, relative permeability of 64,000. Relative permeability means you have mu r given as 64,000. Now when a magnetic field of 10 ampere per minute is applied, magnetic field of 10 ampere per minute, magnetic field is H. H is given as 10 amperes per minute. So we have mu r and magnetic field H. So what is this? This is magnetic field, and the other is called as relative permeability. So relative permeability and magnetic field are given in the question. What inductance? In the question it is asked inductance. Inductance means it is flux. Inductance means flux density. So represented by B. So B is equal to mu H, but mu is the permeability of the medium, permeability of the material or medium. H is the field, magnetic field. So H is already given, but mu is not for the medium. The mu is given in this question is relative permeability. So we need to calculate mu by using the equation mu r mu naught. We studied these equations before, as you could see here, 4 pi into 10 raised to minus 7. So here mu r, relative permeability, how much is the relative permeability given in the question? In the question it is given as 64,000 multiplied by mu naught is constant for all vacuum. Vacuum permeability of vacuum is constant, 4 pi times 10 raised to minus 7. For all the calculations, mu naught is constant, 4 pi times 10 to the power minus 7, and 64,000 is the relative permeability. When you multiply them, you get mu r mu naught, which is you get the permeability of the medium. So mu, the permeability of the medium is you got it as 0.0804. So after getting mu, if you substitute here, you have already H 10 ampere per minute, and mu you calculated from here, mu r mu naught. When you substitute here, you will get the inductance or the flux density. As you could see here, mu is equal to mu r times mu naught. Mu r is the relative permeability multiplied by mu naught is 4 pi times 10 to the power minus 7, which is a constant. You get mu, value of mu. Then B is equal to mu H. This is the inductance we need to find. Mu we calculated from here. Then H is already given in the question as magnetic field 10 ampere per minute. When you substitute it, you get 0.804 Tesla. The unit is written as Tesla. Magnetic field density is the unit, and then I is equal to. So now we have the first answer. What inductance is obtained? What inductance is obtained? That is B. The first answer for this question, you got it from here. This is your first answer. This is your first answer. So first answer is given in here. You can see here. This is called the inductance, or we call it as flux density. This is the answer for first question. Now, when we go to the next part of the question, we have what current is needed to obtain this inductance in a 200 turn 30 millimeter long coil. So how to find this? What inductance in a 200 turn 30 millimeter long coil? So how to find it? So do you remember the equation for a coiled conductor? If the question is general, you can use it. The specific, you have to use empirical equations, which I gave it in the later stage of the class. Now here, this is the L. And how many number of turns we have? We have n turns here in the coil. So this is a coil, as I explained before. And the coil has n turns. The length of the coil is n. Then if I pass a current I through the coil, then I can write H, the field, magnetic field produced will be Ni over L, the length. This equation is corresponding to a general equation for finding magnetic field strength. If number of turns are N and I is current, amount of current, and L, this is L. L is the length of the coil. So this is a general equation, but when we come to our test, if depending on the specific conditions, we add the constants, we may get a constant also in this equation. But here, since it's a general question, we need to find I. From here, we can write I equal to, we can find I equal to HL divided by N. H is the magnetic field, which is given as 10, and length is given. How much is the length given? Length is given in the question as 30 millimeter. Length is 30, so I will write 30 times 10 to the power minus 3. Length is 30 divided by N. How many number of turns in the question? If you see here N, the number of turns given, length given, correct? So number of turns in this question is equal to 200 turns. So I will write 200. So I will get changed to, you can calculate I as 1.5 milliampere. This is the final answer. Is that clear? So from the basic equation of H equal to, Ni over L, we get I is equal to H times L divided by N. H already given in the question. L is given 30 millimeter, converted into meter, divided by number of turns. You will get I. So this is the final answer, and the unit is milliampere. Any doubt in this question, please? I can explain if you need any clarification.
Clear,
Doctor. If it is clear, I will proceed to my next question. So the next question is a similar question. You can see here an iron 80% nickel alloy has a maximum relative permeability of 30,000. So here in the question we have we have the value of mu r, relative permeability 300,000. It is given, And when an inductance of, again inductance, you know it is B, which is the flux density. You know about inductance, which is flux density B equal to 0.35 Tesla. And you know it is equal to mu H, permeability of the medium. Okay, not relative permeability, not permeability of the vacuum, permeability of the medium times H. H is the field strength. H is the field strength. Now, B is given. The alloy is placed in a 20 turn coil. Here the number of turns in the coil is given as 20. And the length of the coil is given as length also 20 millimeter. You have to convert it into meter by multiplying -3. Then what current must be we should feed through the conductor to obtain this field? So we need to find I. We need to find I. So this question, so if you want to find I, basically you know the equation for H, the field, is Ni over L. You have N, you have you don't have I, you need to find I. You have L, I you don't have, but H also you don't have. Can you get H from somewhere to substitute here to find I?
Yes.
Yeah, from
E
B.
equal mu H.
Correct. Very good.
Yes.
From here, B equal to mu H. So what we do here in this question, we write the equation B is equal to, B is equal to mu H. And here B is given, H is given, but mu we don't have. How to find mu is similar to the last time, relative permeability times permeability of vacuum. This is vacuum, this is relative permeability, but the relative permeability is already given in the question as 30,000. So what we have is 30,000, 300,000 multiplied by permeability of vacuum, which is mu naught. You will get permeability of what? Of the material or of the medium, whatever medium you are using, if it's a coil, whatever it is. So this becomes permeability of the medium, and B is equal to mu H. You have mu this value. You have mu this value, then substitute mu here to get B. So sorry, B is already there. B is already there. So B is equal to mu H, and you got mu. B is given. Find H. B over mu. You can see here we get H, which is equal to mu over, sorry, B over mu. You will get, what is H? H is called magnetic field. H is the magnetic field. So we got H from here, and then once we get H, okay. So this is the equation. What is, okay. This is H, this is ampere raised to -1, okay, ampere per meter, okay. Now H we got, then what about I? I, similar to the last time, what I explained, Ni over L equal to H, we get I equal to H times L divided by N. So H we calculated from this equation, substitute here, this H will come, sorry, this H is here, this H will be here, N is already given, okay, using this H, L, this is H, sorry, this is, there's a problem with this, just a minute, okay, this is H, this is L, and this is N, number of turns. You get current required to produce this. So these examples, two examples, the second example is clear. Any doubt you can ask. It is similar to the first one. Second example,
Yes.
if you have any
Yes,
doubt
clear.
you can ask. It is clear, right? It's similar. Yes. It is exactly same. Now, this is what I am explaining is general case. But when we go to our magnetic particle inspection technique specifically, we may have some small changes in the equations, etc., depending on AC source, depending on DC source, etc. Now we go to our next question, which is given here. This is, you can see the question given here, which is we have a magnetic crack detection technique. We have here, this is the magnetic crack. This is specific question. The other two questions what I took is general to how to produce magnetic field, etc. Here this is specific magnetic crack detection of defects. We need to find the defects in the circumferential welds in a 6-inch diameter pipe. So we are really testing a pipe. You could see here, this is a pipe, and the diameter of the pipe is given as 6 inches. So 6 inches is the diameter of the pipe. And also the length of the pipe is given as 1 meter. So 1 meter is the length of the pipe, that is also given. And see here the thickness, wall thickness, the thickness here. This is called the thickness. The wall thickness is T, which is given as 0.25 inch. So the wall thickness is also given here. This is the 0.25 inch, the wall thickness. Now, how many number of turns in here the coil has? This is 1 turn, 2 turn, like that. We have 6 turns given in the question. Is wound around the pipe. So we need to test in magnetic particle, we need to test a pipe. So the pipe has a diameter 6 inch, that is outside diameter 6 inch. Its wall thickness is given as 0.25 inch. Now we have a coil here. This coil has 6 turns. So N number of turns is equal to 6. And we need to wind, the cable is wound around the outside surface of the pipe. So the question is, if we do like this, we are supplying a current of 100 amperes if it is AC and if it is DC. Okay, so how much current I am passing through it? I am passing 1000 ampere through this. Current is 1000 ampere. If I am passing 1000 ampere current through this material, what should be the minimum space required between the turns? This is one coil, 1 turn of the coil. This is turn, this is third turn, like that 6 turns we have. The question is, what if you are a tester or inspector, what spacing you will give here? Why the spacing between the coils? So that you are giving 1000 ampere through supplying 1000 ampere through the coil to test 6-inch pipe with a thickness of 0.25 inch. I hope that the question is clear. Is the question clear to you? Question?
No, doctor.
Again, doctor.
Okay.
Doctor.
The question, okay, I will explain the question again. Just listen carefully. We need to test a pipe, okay? We need to test a pipe. The pipe has a diameter 6 inch. The thickness of the pipe is 0.25 inch. I need to test it by coil. So when we put a coil over the surface, what will happen when we pass current through the coil? This coil will produce axial magnetic field. So coil will produce magnetic field in which direction, you know? If I put this coil, it will produce in this direction. Sorry, horizontal direction. Okay, horizontal direction. It will produce horizontal direction. See here. See, the coil is circular. Even though the coil is circular, the magnetic field will be axial. This much did you understand? I'm explaining again.
Yes.
We
Yes,
have a
yes.
pipe.
Yes.
Yeah. We have a pipe. We have to test whether there is any crack or not. So the pipe thickness 0.25, diameter 6 inch. See, if we supply current through this coil, this current will produce a magnetic field. That magnetic field direction will be axial. See here, it will be axial. See here, it will be like this. So since the magnetic field is perpendicular to the crack, yes, we can detect it. Otherwise, we cannot detect it. Never think that this coil can produce, never think that this coil can produce a magnetic field like this, circular. No, it cannot produce circular. That is not possible. It can produce only axial. Only axial is possible. So this axial can produce it can detect any transverse crack, like any crack in this direction it can detect. Why? Because the direction of field and direction of crack are perpendicular. That's why we can detect it. I think the question is clear. Now, if you are inspector, you have length 1 meter, you have thickness 0.25, you have 6 turns. So 6 turns, you have a coil that is for testing. This coil is for testing only. You have 6 turns. Where you will put the 6 turns? Like it is continuous, but the spacing, why? Length 1 meter, where will be y? You can put it as a 10 centimeter or 5 centimeter. What should be y? This is the question. Is this question clear to you?
Yes, now clear.
Yeah, this coil is continuous. But why? Minimum y you will provide to test this pipe. The thickness is 0.25, length is 1 meter. What should be y here? The spacing between the coils. So the cable is capable. You can supply a current of 1000 ampere AC and 1000 ampere for DC. In order to explain this question, I just want to show you something we already studied here. Do you remember this? This we studied in our lecture before. This is the similar one. We are using coil, and why we use coil? When we use a coil here, we can produce we can produce which type of which type will produce? Will produce axial like this, right?
Yes.
Yeah, axial can detect this. Now question is, what is the minimum spacing here? Minimum spacing here is the current equation for current. A is the current, a constant 7.5. See here, for DC current is equal to 7.5 times T, the thickness, wall thickness of the pipe, plus y square. Y is the spacing square divided by 40. If it is for a DC source, if it is for an AC source, the current is equal to same constant times 10. So there will not be any T. T is not applicable here. 10 plus y square over 40. These are, as I explained before, some empirical equations which are used to find the spacing between the coils. If you are an inspector, you will substitute these values in here and find it. What will be the field strength at a distance, say x? If x is the distance, what will be the magnetic field strength in this if we use this coil for testing? Okay, at a distance x, what will be the magnetic field strength? That also we can calculate using this equation. So if you come back to our question in here, if you come back to our tutorial here, now we have the tutorial question here. Now we need to find what? We need to find y. So what are the things? Yeah, what are the things given? The things given are
current.
So yes, current, but that is A. Current is here. Yes. Please try to understand. Current is given an ampere, which is current I. You know it. A, and this is constant, and this is for AC source. So AC source, the equation is, for AC source, the equation is 7.5 times 10 plus y square over 40, right?
40.
Yes, 40. This is the equation. We use it for AC source. You can see in here the same equation, whatever we used before. You can see here, this is 40. Have you seen it? For AC source, 40. 10 and 40 are constant. As I explained, these are empirical equations. which are derived from the experiments or experimentation. There is these equations are not from directly from a law, it is from experiments. Okay. Now from here, the minimum spacing required for this application, only y is unknown, the current is given. These are already in the question, so substitute it, find y. So if you are using AC source current, AC current is applied, 1000 AC, then the spacing should be 70 meters. Depending on the source, it may change if you are going for AC. Now let us go and see how much is for DC. Can we use the same equation for DC? No. Equation for DC is the current passed through the medium is equal to constant times thickness, wall thickness. What is that? Thickness of the tube times y is the spacing 40. It is not 40. It is 4 times t. T is the thickness. So here in the question, thickness is given as 0.25 inches. Thickness is given. So directly, if you substitute 0.25 times 4, you get the value as 25.4. 4 times thickness. Thickness is given in the question. You get y here. Y as 56.7. So if you are going for a DC source, depending on the availability of the source you have, you need only 56 millimeter spacing if you go for a DC source. So this is the meaning of this question. So if you are going for AC and if you are going for DC, what spacing? You are an inspector. You are working in the inspection department, what spacing you will apply to get this much of fill, this much of, yes.
Excuse me, doctor, if we
Yes.
calculate 40, the thickness is 0.25. If we multiply 4, multiply by 0.25, it will be 1, not 25.
1 inches, right?
For DC.
Yeah. Need to convert it into centimeter. If you convert it into centimeter, this equation has to be that I was about to explain to you. Where is our question? This is our question, right? Now I will go back. Did you convert it into centimeter? 0.425 inches. This is our question. See here. What is written here? Come on, tell me what is written.
Centimeter.
Centimeter, right?
Yes.
And here this is our this is our question. Okay. Now here, as I told you, whenever we talk about, just let me, yes. Anyway, here, whenever we talk about these equations here, the first equation is A equal to this and A equal to this. These are some constant values. That means there must be some specific values for specific values or specific units for y and t. Since we are using constants like 7.5, 10, 40, etc., and I explained to you these are empirical equations, means from experimental observations. That means this t and y must be in a specific unit as per the equation. That's why in here you can find A is in ampere, definitely in ampere. T, the thickness should be in millimeter, and Y also you will get in millimeter. This is about this equation. If you come here, in here you can find R is in, if you want to find H, this is another empirical equation. R is in centimeter, L is in centimeter, N in number of turns, A is in amperes. So this is the critical in here, as I explained before. These equations are not derived from any specific, not directly derived from any specific law. These are from experiments. Hence, this, if we use this, the y, if we can substitute y in millimeter, you will get. Okay. And 40, if you substitute, you will be getting here directly 70, right? This is okay. First is okay, correct?
Yes.
Now we come here and we have t. This t you must substitute in millimeter. For example, 0.25 inch. 1 inch is 2.53 centimeter. 1 centimeter is 10 millimeter. Can you multiply now? So you will have 2.5 times 2.53. So how much you are getting? Around 6.35.
Yes.
Yes.
Can you multiply this?
0.25.
Yes.
Yes, you are getting this. Yes, you are getting 6.35. That's why
Yes.
6.35 is substituted here for t, and 6.35 times 4, that is 25.4. Is that clear?
Yes, yes.
Yeah, here remember one thing, the current should be, for example, 1000 and the unit is ampere. Y and T are in millimeters. This is the only thing you need to understand in empirical equation. Any empirical equation you take, you must have studied it before also. The units are important. You cannot put standard units like meter, centimeter. Our equation says, that's why in the learning material I have specified clearly, I have specified the units. Have you noticed these units in here and the units in here? You have noticed it, right? T in millimeter, Y in millimeter. Why? Because these are empirical equations. That's why. Is that clear?
Yes,
Yes or
doctor.
no? Clear.
Yes. Yes,
Yes.
Now,
doctor.
yes,
Question. Sorry.
yes, yes.
Now thickness is 0.25 millimeter, right? We change to centimeter.
0.25 inch.
Inch. So
So,
change
so,
in
see,
meter.
look at that 0.25 inch. First, we need millimeter. We need it in millimeter. Okay. See,
So
T should be in
like
millimeter. So first step, I convert it into centimeter, right? Then I convert it into millimeter. That's why I multiply like this.
here. Thank you, doctor.
Clear?
Yeah, clear.
Yeah,
Thank you.
inch to centimeter first, then to millimeter. That's why I multiplied like this. So you got y here, the value of y, the spacing, the spacing between two coils must be 56.7 if it is DC source. If it is AC source, this much. So now I am not aware. I'm thinking whether this H, what is H? Our field magnetic will be enough to detect at a distance x equal to, what is that distance given in the question? At a distance 25 centimeter. I need to find the field strength to make sure that at a distance 25 centimeter from middle, what is the, from the middle, this is the middle, right? From the middle at a distance 25 centimeter, how much will be the field strength? How to find the field strength is, you have radius in, you have radius given here. How much is the radius in the question? Radius is given as 6 inches.
0.5.
Yeah, 6 inches diameter, correct?
Yes. Yes.
So how much will be then radius? I will write here. Radius equal to diameter divided by 2. This is the radius. Diameter is 6 inch by 2, which is equal to 3 inches. 3 inches means 3 times 2.53 centimeter times 10 millimeter. Have you seen it? This will be, we don't need in millimeter, we need everything in centimeter. So up to this, is that clear? Okay. R in centimeter. Now, how much is, so when we substitute all values here, and x is how much here? X. How much is x? 25. So x is, yeah, x is 25 centimeters. So we substitute x
So
equal to 25 centimeter. X is 25 centimeter. Okay. So L by 2. L by 2 is the middle. From the middle, how much it will be? From the middle, how much is, so you take, this is the turns, you take this from here. If you take 25 centimeter, okay, how much? For example, maybe the, how much is the total? See here, How much is the length? 1 meter, right? 1 meter is the length. Okay, 25 centimeter, 25 centimeter. So 25 here, 25 here. What will be the H, the field strength? You have N, the number of turns. You have ampere, the current, 1000. N is 6 turns. Length is 1 meter. Then you have L by 2. All values you substitute, you will get H in the value of H. Can you please do it, solve it, and come back to me in the next class? Whenever we meet in the next class, can you substitute only the field strength? Can you substitute the values and see whether we are getting H 73.53 in the next class? So this is
Doctor,
the, yeah, these two are clear to you. And the next
Yeah.
class, go through the values and find the value of H. Yes.
So doctor, the X is the distance, right?
Yeah, yes.